Hello GATE aspirants, welcome to part 5 of GATE quantum mechanics series. Question number 9. The recoil momentum of an atom is Pa when it emits an infrared photon of wavelength 1500 nanometer, and it is Pb when it emits a photon of visible wavelength 500 nanometer. The ratio Pa by Pb is. Now we know de Broglie wavelength lambda is equal to h by P, so P is equal to h by lambda. So Pa upon Pb is equal to lambda b upon lambda a, which is equal to lambda b is 500 nanometer and lambda a is 1500 nanometer. So this is equal to 1 by 3. So option C is correct. Next question. The ground state and the first excited state wave functions of one-dimensional infinite potential wave are psi1 and psi2 respectively. When the two spin-up electrons are placed in this potential, which one of the following, with x1 and x2 denoting the positions of the two electrons, correctly represent the space part of the ground state wave function of the system? Now here both electrons are spin-up electrons. That means spin part of the wave function is symmetric. And if spin part is symmetric, then space part has to be antisymmetric. As these are fermions, the total wave function has to be antisymmetric. So space part will be antisymmetric. So here option D is correct. Out of the options given to us, option D is antisymmetric wave function. Next question. If L bar is the orbital angular momentum and S bar is the spin angular momentum, then L bar dot S bar does not commute with. Now we know commutation relation L square LR is equal to 0 always. Also L square SR, this is equal to 0. S square LR is equal to 0 and S square SR, this is also equal to 0. Now if we consider L dot S, then that is equal to Lx Sx plus, just dot product between these two vectors, Ly Sy plus Lz Sz. Now if we consider L square and L dot S, then L dot S is this, and we can expand it using multiplication rules, and since all these terms are equal to 0, then that means this will also be 0. And also S square L dot S, this will also be 0. So this is 0. Now we also know Li and Lj, this is equal to I h cut Levi-Civita tensor Ijk Lk and Si Sj, this is equal to I h cut Levi-Civita tensor Ijk L Sk, and also Li Si or Sj, anything, this is equal to 0. This is known to us. Now out of these options, for option B and C, we know that it commutes. So B and C is not correct option. Now we have to check for A and D. Now if we check for D, D is L bar plus S bar square. So that is L square plus S square plus 2 L dot S, and here we have L bar dot S bar. Now this will be L square L dot S plus S square L dot S plus 2 into L dot S L dot S, and that is also going to be 0. So here option D is wrong. So here option A will be correct, that we will check now. We have Sz and L dot S is this, so this will be Lx Sx plus we have Sz, then second term will be Ly Sy, Sz, then Lz Sz. So this will be equal to, now we know Li Si is equal to 0. So using multiplication rule we can expand this. So this will be Lx Sz Sx plus Ly Sz Sy plus Lz Sz Sz. So this will be equal to Lx, this is I h cut Zx, so this will be Sy plus Ly Zy, so minus of I h cut into Sx Lz into 0. So we can take this I h cross common. So I h cut Lx Sy minus Sx Ly. So we are getting this. So that means, and this is not equal to 0. So it is not competing with Sn. So option A is correct. Next question. Here it will be Ly Sx. We can't change the order. So this will be Ly Sx. Next. Question number 27. An electron in the ground state of the hydrogen atom has the wave function psi of r is equal to 1 upon under root pi a naught cube e raised to minus r by a naught, where a naught is a constant. The expectation value of the operator q, which is equal to z square minus r square, where z is r cos theta. That means q is equal to r square cos square theta minus r square. So we can take this r square common. Expectation value of q, that is equal to psi q psi, and this is normalized state, so we don't have to worry about psi dot psi. So this will be equal to square of psi, so that will be 1 upon pi a naught cube, and then we have integration over e raised to square of this, so minus 2r by a naught into q, that is r square. We can take r square common, and in bracket we have cos square theta minus 1 into d tau, and d tau is r square sin theta dr d theta d phi. Now we can separate this integrations. So this will be equal to 1 upon pi a naught cube. Here we have r square into r square, so that is r raised to 4 e raised to minus 2r by a naught dr. Then this integration is from 0 to infinity. Then here we have cos square theta minus 1. So 0 to pi cos square theta minus 1 into sin theta d theta, and lastly 0 to 2 pi d phi. So this will be equal to 1 upon pi a naught cube. Now this integration will be, this is integration of r square e raised to minus 2r by a naught. So that will be equal to 4 factorial upon this is a, so a raised to 4 plus 1, that is 5. So that is 2 by a naught, the whole thing raised to 5. Then integration of cos square theta, derivative of cos theta is sin theta, so that is adjusted here, minus sin theta. So this will be minus of cos cube theta by 3 minus integration of minus sin theta, that is plus cos theta, and limits 0 to pi, and d phi is 2 pi. So this will be equal to, this pi and pi will cancel. Now we have 4 factorial, so 4 into 3 into 2 upon a naught cube into 2 raised to 5 is 32 into a naught raised to 5 into this 2 from this 2 pi, and then cos cube theta, cos pi is minus 1, so minus 1 raised to 3 is minus 1, so minus 1 plus 1, so 1 by 3. Then cos pi is minus 1, cos 0 will be 1, so this is minus of minus 1 by 3, so plus 1 by 3, and cos 0 is 1, so minus 1. So this is equal to, this 2 and 2 will cancel, this 4 will cancel out, so we will get here 4 to the 8 into 2 is 16, so that is 3 upon 2, and a naught raised to 5 upon a naught raised to 3 is a naught raised to 2, and 1 by 3 minus 1 by 3 plus 1 by 3 minus 1, that is minus 4 by 3. So this is equal to minus 2 into a naught square. So here option D is correct. Next question. A particle of mass m is subjected to a potential V of x is half m omega square x square plus y square. The state with energy 4 h cut omega is g fold degenerate. The value of g is. Now this is 2-dimensional quantum harmonic oscillator. So that gives us energy En is equal to nx plus half into h cut omega x and ny plus half h cut omega pi. Here omega x and omega y is same, omega only. So this is equal to nx plus ny plus 1 into h cut omega. And this is given, this is equal to 4 h cut omega. So that gives us nx plus ny plus 1 is equal to 4. So nx plus ny is equal to 3. Now nx and ny can take this value 0, 3 or 3, 0 or 2, 1 or 1, 2. So 4 such combinations are possible. So degeneracy is equal to 4. Or you can directly remember this formula for two-dimensional simple harmonic oscillator. Degeneracy G is equal to nx plus ny plus 1. So that is 4. Directly from here you can write it. And answer given in the answer key is 3.99 to 4.01. Answer is 4. Next question. A hydrogen atom is in the state psi is equal to under root 8 by 21 psi 200 minus under root 3 by 7 psi 310 plus under root 4 by 21 psi 321, where n, l and m in psi and lm denote the principal, orbital and magnetic quantum numbers respectively. If L bar is the angular quantum operator, the average value of L square is. Now, average value of L square is equal to psi L square psi upon psi psi. Now, square of this will be 8 by 21 plus, or we can directly write and then check. So, this will be, L square will be operated on this. Now, L square operated on psi gives us L plus 1 into h cut. Now, in the first case, L is equal to 0, so that will be 0. For the second case, it is 1. So, this will be equal to, this can also be written as Ci square, and then you can operate L square on it. L square operated on psi upon summation over Ci square. So, this will be 8 by 21 into 0 plus 3 by 7 into 1 into 1 plus 1, that is 2 h cut square. And lastly, we have 4 by 21 and 2 into 3 into h cut square. Upon we have 8 by 21 plus 3 by 7 plus 4 by 21. So L square will be, this is 0. This will be 6 by 7 h cut square plus 4 to the 8 by 7 into h cut square upon 8 by 21 plus 3 by 7 plus 4 by 21. This is equal to 1. So this will be 14 by 7 h cut square, that is 2 h cut square. So this will be 2. Answer will be 2. And answer given in the answer key is 1.99 to 2.01. Next question. Psi 1, Psi 2 are two orthogonal states of a spin half system. It has given that Psi 1 is given, where 10 and 01 represent the spin up and spin down states respectively. When the system is in the state Psi 2, the probability to be in spin up state is. Now Psi 1 is given, we have to calculate what will be the value of Psi 2. And it is given that these are orthogonal states. So Psi 2, Psi 1, this will be equal to 0. That means, let us assume that Psi 2 is C1 10 plus C2 01, and we will find C1 and C2. So that means C1 1 by root 3 plus C2 under root 2 by under root 3. This is equal to 0. That means C1 is equal to minus of root 2 times C2. Also, C1 square plus C2 square is equal to 1, because that will be a normalized state. Then in that case, C1 square will be root 2 square, so that is 2C2 square plus C2 square is equal to 1. That gives us C2 square is equal to 1 by 3. So C2 will be 1 by under root 3, and that gives us C1 is equal to minus of under root 2 under root 3. So psi 2 will be 1 by root minus 1 by minus root 2 by root 3 1 0 plus 1 by root 3 0 1. So that will be second state. Now probability of getting 1 0, so that will be C1 square, and that is 2 by 3. So that is equal to 0.67. So answer is 0.67, and answer given in the answer key is 0.66 to 0.68. Next question. A particle is confined to a one-dimensional potential box with a potential V of x is equal to 0 in the range 0 to a and infinite otherwise. So this is infinite potential well. If the particle is subjected to a perturbation within the box, W is equal to beta x, where beta is a small constant, then the first order correction to the ground state energy is. Now first order correction E11 is equal to psi 1 and that function, perturbating function, into psi 1. Now psi 1 is ground state wave function, and this is given to us. This is beta x. So beta is constant, so we can take it out. This is psi 1 x psi 1, and this is average value of position only. So that is beta into average value of position, and average value of position in ground state, that is equal to a by 2. So E11 is equal to beta into a by 2. So here option C is correct. Next question. A one-dimensional harmonic oscillator is in superposition of number states n given by this. The average energy of the oscillator in the given state is. Now average energy of oscillator, this is equal to summation over Ci square upon summation over Ci square. So 1 by 2 square is 1 by 4, and here we'll have E2 plus 3 by 4, then E3 upon 1 by 4 plus 3 by 4, which is equal to 1. So this is 1 by 4 into. Now this is harmonic oscillator. So En is equal to n plus half h cut omega. So when we put 2 here, this will be 5 by 2 h cut omega plus 3 by 4, and next state will be 7 by 2 h cut omega. This is equal to 5 by 8 plus 21 by 8 h cut omega, that is 26 by 8 h cut omega, that is 13 by 4, which is equal to 3.25 h cut omega. So answer is 3.25, and answer given in the answer key is 3.2 to 3.3. Next question. If L plus and L minus are the angular momentum ladder operators, then the expectation value of L plus L minus plus L minus L plus in this state of atom is. Let us first calculate it. L plus L minus and plus L minus L plus. This is equal to L plus is Lx plus ILy, and L minus is Lx minus ILy, plus we have Lx minus ILy and Lx plus ILy. We'll multiply it and separate it. So this is Lx square plus I Ly Lx minus I Lx Ly, and this will be I square Ly square, so that is plus Ly square, plus Lx square minus I Ly Lx plus I Lx Ly plus Ly square. So this is 2 times Lx square plus Ly square, and this is equal to L square plus Ly square is L square minus Lz square, which is equal to L plus 1 into h cut square minus ml square h cut square. So this will be equal to, now L is given, L is 1, so this will be 1 into 2, so 2 h cut square minus m is 1, so 1 square is 1, so 1 h cut square. So this will be 2 h cut square. So answer is 2. And answer given in the answer key is 1.99 to 2.01. So these were all the questions from GATE 2014 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.